Is Africa slowly breaking apart? According to scientists, a huge plume of hot magma rising from deep inside the earth is pushing the continent from within. This force is breaking the land and may one day create a brand new ocean and split Africa into two.
For centuries, the great landmasses of the world have appeared unchanging to casual observers. Mountains stand resolute, deserts stretch as far as the eye can see, and continents appear to be fixed in place. Yet a deeper look into Earth's geological past reveals a planet in constant motion, where tectonic plates shift, collide, and sometimes tear apart. It's easy to forget that the continents we know today were once fused together in a supercontinent called Pangaea, before separating into the familiar shapes we see on maps. In Africa, this planetary dance is playing out in real time. The East African Rift System, a massive geological feature that stretches thousands of kilometers from the Red Sea through eastern Africa, is not just a mere surface crack. It's a sign of transformation on a tectonic scale. Scientists have long known about rift valleys, but new research and data from as recently as 2025 now underscore a remarkable possibility. Eventually, a new ocean may form, splitting the continent into separate land masses. To understand why Africa might eventually be split into two distinct landmasses, we first need to understand how tectonic plates work. The outermost layer of the Earth, known as the lithosphere, is stretching over 3,000 kilometers, about 1,864 miles. This rift is essentially a system of geological cracks where the African plate is slowly splitting into two. The Nubian plate, which comprises most of the African continent, and the Somali plate, which includes the Horn of Africa region. The boundary between these two plates is where the crust is thinning, just like bread dough stretched so thin that holes begin to appear. Seismic measurements, satellite data, and geophysical surveys have allowed researchers to monitor the rate of this splitting. While the movement may seem imperceptibly slow on a human timescale, averaging a few millimeters to centimeters per year, the long-term consequence could be monumental: the eventual birth of a new ocean basin. The notion of a future ocean forming in East Africa wasn't formalized overnight. Let's journey through the timeline of critical developments that led scientists to this astonishing conclusion. Early 20th century. Geologists began to systematically study rift valleys and propose that continents could tear apart. However, technology at the time limited their ability to observe large-scale tectonic movements in detail. 1960s. Satellite geodesy started offering more precise measurements of Earth's surface, bolstering the acceptance of plate tectonics as the unifying theory of geology. Researchers noted the presence of seismic and volcanic activity in the East African region, hinting at a rifting process. Late 1990s. Improved GPS, Global Positioning System, technology allowed scientists to track the movement of tectonic plates in real time. Measurements confirmed that the African continent was indeed splitting along the East African Rift, at rates of about 2 to 7 millimeters per year in various segments. 2018 to 2020, large fissures appeared in southwestern Kenya, garnering widespread media attention. This visible crack in the ground sparked renewed global interest in the rift's progression. 2023-2025, enhanced radar satellite imagery from ESA and NASA missions provided higher resolution data. New geological surveys revealed that the thinning of the crust along parts of Ethiopia and Kenya is accelerating, reinforcing predictions that a fully formed ocean basin could begin to emerge, albeit over millions of years. Fast forward to 2025, and the East African Rift System displays a remarkable array of geological activity that underscores the intensity of tectonic forces at play. In parts of Ethiopia, ground deformation studies using INSAR, interferometric synthetic aperture radar, show shifts that measure up to a few centimeters per year. Concurrently, localized volcanic activity in regions like the Afar Depression provides a dramatic visual clue to the ongoing processes beneath the crust. In Kenya's Rift Valley, new crack formations and frequent seismic swarms have captured the attention of both the public and scientific communities. Researchers from the University of Addis Ababa and other institutions have compiled comprehensive subsurface data, demonstrating that magma intrusions into the lower crust are increasingly common. These intrusions are essentially forming pathways that facilitate further splitting, akin to how repeated stress on a piece of metal eventually snaps it in two. While it remains an extremely slow process on a human timescale, these incremental changes are crucial pieces of the puzzle. Moreover, a recent report from the African Union's Geological Commission, published in March 2025, highlights that parts of the rift in Ethiopia and Eritrea are experiencing the highest strain rates. The data not only confirms what geologists suspected, but also offers a clearer understanding of which segments of the rift might host the earliest stages of an embryonic ocean basin. To appreciate the magnitude of what's unfolding in East Africa, let's compare it to other rifting environments around the world. Consider Iceland, situated atop the Mid-Atlantic Ridge, where the North American and Eurasian plates diverge. There, the spreading rate averages around 2.5 centimeters, 1 inch, per year. In the East African Rift, estimates vary across segments, from as slow as a few millimeters per year to nearly 2 centimeters in some places. Although the numbers may seem small, it's the cumulative effect over geological timescales that holds significance. In places like the Red Sea and the Gulf of Aden, both of which are younger ocean basins formed by rifting, the rate of separation is generally faster, about 1 to 2 centimeters per year. These sea basins give scientists a living laboratory to study how continents transition into oceanic plates. Comparatively, the East African Rift is at an earlier stage, but the fundamental processes are the same. Interestingly, the Great Rift Valley, which encompasses the East African Rift, is also known for its string of large lakes, including Lake Victoria, Lake Tanganyika, and Lake Malawi. The presence of these deep lakes signals that water is already collecting in rift-generated depressions. While it may take millions of years for a fully fledged ocean to form, the lakes serve as miniature examples of how the Earth's crust responds to rifting. As the rift widens, it is believed that seawater from either the Red Sea or the Indian Ocean will eventually flood into these low-lying areas, forming a new ocean basin over time. While these rifting processes are fascinating from a scientific standpoint, they come with a host of practical challenges for the people who live in East Africa. Tens of millions of individuals inhabit regions that are seismically active. Although high-magnitude earthquakes in the region are not as common as along subduction zones, the numerous moderate quakes and rift-related fissures can cause infrastructure damage. The sudden appearance of large cracks in roads and farmland in Kenya during 2018 and again in 2022 disrupted local communities, highlighting the immediate human implications. In addition, the ongoing thinning of the crust can lead to increased volcanic activity. Areas near active or dormant volcanoes face the risk of lava flows, ashfall, and hazardous gases. The 2025 updates from the East African Volcanic Activity Monitoring Project indicate a rise in minor volcanic eruptions in the Afar Depression of Ethiopia. Though these eruptions are relatively small compared to cataclysmic eruptions elsewhere, they can still disrupt air travel, agriculture, and day-to-day life. Water resources are another turning point. The formation of deep fissures can reroute groundwater systems, impacting wells and springs that local communities rely on. As scientists project greater rift activity in coming decades, policymakers in East Africa are increasingly focused on infrastructure planning, emergency preparedness, and water management strategies to mitigate the risks that accompany the slow birth of a new ocean. From a geological perspective, the East African Rift System offers a spectacular opportunity to study continental breakup in real time. Scientists across the globe consider this region a natural laboratory, enabling direct observation of phenomena that shaped ancient supercontinents and ocean basins. Yet there is more to this story than just geology. Economically, the rifting can have complex impacts. On one hand, volcanic soils near rift zones are generally fertile, supporting agriculture in regions like the Ethiopian highlands and parts of Kenya. The development of geothermal energy is also gaining momentum in places like the Olkaria geothermal field in Kenya, where the rift's heat source provides a sustainable energy option. Indeed, recent data from 2025 indicates that Kenya has increased its geothermal energy output by an additional 200 megawatts over the last 3 years, reducing dependency on fossil fuels. On the other hand, continued fracturing could hamper the development of roads, railways, and other critical infrastructure, especially if cracks form suddenly. Environmentally, new ecosystems could eventually form in flooded rift basins, creating habitats for various species. However, these transitions could also displace local flora and fauna. Conservationists highlight that any drastic changes to water flow and terrain could destabilize ecosystems not just in the rift itself, but in a ripple effect across the region. Balancing economic opportunities, like mining for valuable minerals exposed by tectonic activity, and environmental stewardship will remain a central challenge as rifting progresses. How does a rift transform from an inland valley to a full-fledged ocean? The process can be broken down into a few key stages. First, mantle plumes, or hotspots, weaken the lithosphere from below, causing it to bulge and fracture. This explains why regions like the Afar Depression, near the junction of three tectonic plates, experience intense volcanic and seismic activity. As the crust stretches and sinks, faults form, and the area between them subsides, creating elongated valleys, such as those seen in East Africa. Next, magma intrusions widen these fractures over time, and the valley floors may sink below sea level. In East Africa, many rift segments are still above sea level, but a few areas, like the Danakil Depression, already lie below it. According to a 2025 review in the Journal of African Geosciences, the rate of subsidence in some sections of the rift has doubled over the past 2 decades. Eventually, if the Rift Valley connects to a nearby ocean, seawater can flood into the basin, giving birth to a new ocean. Over millions of years, the rift edges continue to diverge, thickening the oceanic crust in the middle and definitively separating the new ocean from the original continent. In essence, the East African Rift is in the earlier stages of this multi-step transformation, providing modern-day scientists with a glimpse into the same processes that once shaped the Atlantic Ocean, the Red Sea, and beyond. One of the most important developments in recent years is the expansion of advanced remote sensing projects that gather data on East Africa's tectonic shifts. The year 2025 has seen the launch of new satellites equipped with next-generation radar and optical sensors capable of detecting minute changes in the Earth's surface. These satellites, operated by international collaborations involving agencies from Africa, Europe, and North America, produce near real-time data on fault line activity, crustal deformation, and volcanic emissions. Preliminary results indicate that certain segments of the rift, especially in northern Kenya and southern Ethiopia, are widening at slightly accelerated rates compared to measurements from the early 2010s. This acceleration is still within a range of millimeters per year, but consistent detection of incremental speedups suggests that local conditions, such as magma availability, fault line geometry, and regional stress distribution, can vary significantly. Moreover, new geochemical analyses of volcanic rocks along the rift margins show a higher concentration of specific trace elements, hinting at deeper magma sources feeding into the rift. In a recent regional forum held by the Intergovernmental Authority on Development, IGAD, policymakers reviewed the updated geological data and discussed strategic measures for infrastructure resilience and sustainable development. As of 2025, the consensus among geologists remains that while the final separation of Africa into 2 continents and the formation of a new ocean is still far in the future, tens of millions of years, these new findings emphasize the dynamic and ongoing nature of continental rifting in East Africa. What lies ahead for Africa as it slowly prepares for a seismic transformation that could redefine its geography? In geological terms, it's only a matter of time, albeit millions of years, before the Somali Plate drifts far enough to allow ocean water to flood the rift zone. When that happens, Africa will effectively be split into 2 distinct landmasses, and a brand new ocean will be added to our world map. This prospect, while almost unfathomable in a human lifetime, underscores the relentless power of plate tectonics. For the people who call East Africa home, the rifting process presents a future full of both uncertainties and opportunities. Advances in satellite monitoring and geological surveys enable better hazard assessments and infrastructural planning. national and regional bodies can use these insights to build more resilient communities, invest in geothermal energy, and manage water resources more effectively. At the same time, there is a responsibility to protect and study unique ecosystems forming around the rift's lakes, volcanic fields, and emerging landscapes. Ultimately, the story of a new ocean forming in Africa encapsulates our planet's long history of constant change. While human history spans mere thousands of years, Earth's geological saga unfolds over eons. By understanding these processes better, we not only unravel the mysteries of our planet's past, but also prepare to adapt for the future. The East African Rift is a vivid reminder that no continent, no landscape, is permanent. Instead, we inhabit a world in perpetual motion, shaped and reshaped by the titanic forces beneath our feet.